Here we go. Okay, so, ladies and gentlemen, you cannot not know how to solve equations. We gotta know how to solve equations. Balance point, distribute if needed. We do. 3 times 2x, 3 times negative 7 gives me 6x minus 21 plus 5x equals 4x minus 5. Combine like terms, 6x's plus 5x's is 11x minus 21 equals 4x minus 5. Subtract 4x from both sides, gives me 7x minus 21 equals negative 5. Add 21 to both sides, gives me 7x equals 16. Divide by 7. Well, I can divide this by 2, not this one. 7's a prime number. The only thing that I can divide 7 by is 1 and 7. 16 doesn't get divided by 7, so we keep it as 16 sevenths. You will begin seeing more and more equations that have answers as fractions. I'm going to start prepping you for the ACT. Yes, I know you are freshmen, but it's not just 1 year. It's an accumulation of things. Everybody with me? Okay.
7 over 16.
Then you did it backwards. It would be incorrect. So you divided this 16. Remember, the goal is to get x by itself. So we need to isolate that by moving whatever's with the x away.
Oh.
You with me?
Yeah.
Okay. This one's cross multiplication. It's a proportion. This is a proportional relationship. That's going to be key today. Okay? So this means 8 times x plus 1 equals 10 times x minus 1. Give me a thumbs up if you guys got that at least first step, just the cross multiplication, right? Okay, so now we're going to distribute 8x plus 8 equals 10x minus 10. And I hope that I did this one right. That gives me 8 equals 2x minus 10. Add 10 to both sides. That gives me 2x equals 18. Divide by 2. X equals, that would be incorrect. X equals 9. Let's make sure 9 minus 1 is 8, 9 plus 1 is 10. That works perfectly. Questions? We good? Anybody? Okay, get a clean piece of paper out. So it is Veterans Day. So thank you, veteran. Thank you, veteran. We're talking about direct variation. So this is part of graphing and functions. This is going to lead us into graphing with slope, linear equations. This is, oh bless you sir, this is algebra, okay? I told you there's 2 things that you have to know. You have to know how to solve equations and you have to know functions. This is part of the functions. So, I told you at the beginning it's going to require a lot of writing. But I'm going to try to make it make sense. I'm going to keep numbers small to start. So even though you're like, it's a real world problem, it doesn't quite make sense, but it's fine, okay? You ready? So here's our first example. We go to the gas station. And buy my favorite candy bar, which is Snickers. Buy a Snickers bar. One Snickers costs $2. Okay? Yeah? That sounds about reasonable, right? Yeah, okay. So you should be copying this down. You want to have this in your notes, I promise. How much will 5 Snickers bars cost? This is a question that should be common sense like, not even math like. So copy it down and then I want to hear what you're going to say. Okay? Okay. So, we go to the gas station. There's a real world problem, right? Who's not been to a gas station to buy candy? Yeah, we've all done that, right? Like, it's a real thing. Okay. We probably haven't gone in and like, man, I want 5 candy bars. We probably haven't done that until you're a parent, and then you're on a road trip and you have Cole going, I want this, and Leon going, I want this one, and then you're like carrying bags of food out, but it's a road trip and you always get stuff. Don't give me that look. It's gonna be delicious. So, how much do 5 Snickers bars cost? Why? How did you, wait a minute. Maybe, listen. I know that I'm not the smartest man in the world. I know that I struggle a little bit in math. So I need some help. How did you get $10? Because I'm not seeing it. I don't agree. How did you get that?
Because if they cost $2.
If what? Costs $2.
Snickers.
Okay, wait. So, you're saying you have something in your head. You're saying there's a Snickers bar and there's a cost. Okay. So, go ahead. You're telling me what?
The Snickers bar, you have 5 of them.
Wait, but what do I start with? How did you get anything else? What does it say to start?
$2
Was what?
the cost of the Snickers bar.
Of how many?
Of 1.
Oh, so 1 costs $2. Okay. And then what? You said 5 is, tell me. Well, how did you get the 5 is 10?
Because 2 times 5 is 10.
Oh. So you're telling me that 2 costs $4. What would 3 cost?
6.
What about 4?
$8.
And it will keep going up like this. Could I easily make this table?
Yeah.
Yeah, that's an easy table to make, right? This is direct variation. This is proportional. But now here's my question. What if I wanted 100 million Snickers bars? What would I multiply 100 million by?
2.
Oh. So what you're telling me, so Snickers bars and cost. Does everybody agree that this table is correct?
Yeah.
Kendall, I haven't heard from you. Do you think that this table makes sense? Okay. Which
Actually,
one's my x value? Which one's my y value?
1. Oh wait.
We're assuming there's no x.
This is Snickers bar. That's the X. And
Okay.
the money is the Y.
So now I'm going to ask you a question. Can we make an equation to find what we call n number of Snickers bars? We don't know what the number is, but we're going to find it. So you're telling me that you're multiplying the number of Snickers bars by what?
2.
So I'm taking 2 times x equals what? The 2 times 1 gives me $2. 2 times 2 gives me $4. So what does the 2 times the number of Snickers bars give me? The cost, which is y. This is direct variation. Direct variation is in the form of y equals, this number is called k, x. Direct variation. So now we're going to want to write this down. K is the constant, and that is the most important thing. When we say our God is constant, what does that mean about God? If God is a constant in our lives, He is unchanging. He is never going, like there's songs about God never changes. He is a constant in our lives. We know who our God is day in, day out. Never changes. The same thing happens in a linear equation. There must be a constant. It is unchanging. To find the constant, what's 4 minus 2?
2.
What's 2 minus 1?
1.
To find the constant is found by doing y divided by x equals the k. 2 divided by 1 is? What's 2 divided by 1? Oh, what if I do this? What about from 10 to 4? What's the difference? What's 10 minus 4?
Oh, 6.
What's 5 minus 2?
3.
What's 6 divided by 3? 2. Wait a minute. The constant doesn't change. Now, again, you're saying I'm making it complicated. You're right. I am a little bit. Could we graph this? Could we graph showing how much the candy bars are? Sure. Watch this. So I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. One candy bar cost $2. 2 was 4. 3, 6, 4, 8, 5, 10, whatever that is, okay? Now, look at my line. Can it go negative? Can we have negative candy bars? No. But, Mr. H, what about this point that's here at 0, 0? For direct variation, if it doesn't pass through the origin, it is wrong. Why? If I buy 0 candy bars, how much is my cost of the candy bars? Yeah, if I don't buy any, it's 0. With me still? Okay. So, here's what we're going to do. You're going to do the same thing, except you're going to set up a table. Okay? Everybody have this copy down?
Not the graph.
Okay, get the graph. I'm going to erase this. Kendall, what do you like shopping for?
Close.
Clothes. What kind? What do you want to shop for today?
Shirts.
Shirts. Okay. How much does a shirt cost these days?
50.
No, I'm not asking y'all. How much is a shirt? A shirt that you want to go buy, how much is it? $13. Okay, so copy this down. Kendall goes and buys 1 shirt for $13. She knows her sister will steal it, so she buys 6. She wants that shirt. How much will 6 shirts cost? 18 shirts? 100 shirts. So I want you to make a table, have an equation, and then we're not going to graph it, but tell me what the constant is. What's unchanging? Okay, so copy that down.
How was surgery?
Okay, I'm not asking you for the whole thing, but here's what I'm asking. What should I label my table? Kendall, what should I label my table? What should be the X, what should be the Y? What do you think?
The X would be shirt.
Yeah, the number of shirts. And? What's over here?
The cost.
Very good. Okay, keep on going. You guys see how we're going to start setting this up? And you don't have to do every number, but do a couple, because once you get to 6, you should start to figure out, man, what's the constant? Because then I can write the equation for those 18 shirts and the 100 shirts. So a couple things that you have to know about direct variation. Direct variation will always have a constant, and it goes through the origin, just like in this problem. If Kendall buys 0 shirts, it's $0. So what's the equation? What do you think it's going to be? Y'all are doing great with the table. Okay, so you don't have to keep going, you don't have to go all the way up to 18. So you've done 6. Can you jump 18? What are you going to multiply? So instead of,
Wait, how many shirts are
18 and 100. So you have 6, you have 18, you have 100. Okay, so most of you did great to this point. I watched you guys do the 2, the 3, the 4, the 5, the 6. What do we get when we have 2 shirts, Alec?
26.
Liam, 3 shirts.
39,
Kendall, 4 shirts.
52,
Isaac, 5 shirts.
65.
And 6 shirts, Alec.
I didn't figure that one out.
Well, do it quick. What are you going to do? What do I take 6 by? 6 by 13, so another 13 should give me 78. So, 6 shirts cost $13. Now, do I need to keep my stuff going? No, I can put 18 and I can put 100 because I can find my constant.
Wait, you just said 6 shirts cost 13.
Oh, I'm sorry. I don't know why I did that. Thank you, sir. 78. I was jumping ahead. How can I find my constant? How can we find the constant? Y divided by x. What's the difference between these? 26 to 13 is 13. And this is 1, so that's 13 divided by 1 is my constant. What's 13 divided by 1?
13.
So k is 13. These are all staying constant at 13. So the equation of all of this is y equals 13x. That is direct variation. Still with me? Now, what do I substitute 18 in for? Where does 18 go into this equation? X or y?
I would have
X, because shirts is x. So what's 13 times 18?
234.
234? So 18 shirts is $234. What do I do with 100?
Multiply it by 13.
Yeah, because we have the constant. It doesn't change. The constant doesn't change. So what do I get?
1,200.
There it is. The hardest part is finding the constant and then substituting it in. That's it. Copy this down and then we're going to do one more example. May I erase the words? May I erase the table? Okay, here we go. Learning a little bit about me. Mr. H is a hopeless romantic. The table shows rose prices he bought. Find the missing spots. So that's question 1. Question 2. Write, or actually, what is K? Write the direct variation equation. So this is going to take a little bit more. You can do this. You need to remember that it's y divided by x. So use your past 2 examples, because you're going to need to find the differences between some things to find that constant. Without the constant, you can't do anything.
What's the dV equation?
That's direct variation equation. What is it?
What do you mean, like?
So the direct variation equation is y equals kx. So once you find k, all you have to do is substitute k in. So remember how we found
Oh yeah,
13?
that's what I did.
You're good, you're good. Do you guys have them? Do you have all of this?
Yeah.
Okay, so you have to tell me the K, so you're gonna put K equals, have each question answered. You guys are, holy moly.
K equals,
Holy moly. I know that, guys, I know that this seems silly. This is not how I've ever taught direct variation. You guys taught yourselves. I've given you an example, you've taught yourselves. This was awesome. All of you have it. So find the missing spots. Before you can find the missing spots, you have to find K. All of you got what K was. What is it? 4. You told me that the constant is 4. To do that, I watched you guys do this. You said 28 minus 16 is 12. This was 3. We know this is y. We know this is x. So I watched you do 12 divided by 3 is 4, which is k.
that's not what I did.
That's all right. What'd you do then? Tell me.
I just divided 16 by 4 and 28 by 7.
Okay, that works for the most part, but I really want you to start taking the difference of the two, okay? Because that's going to lead us into linear equations in a couple days, okay? Awesome. Then the equation, once we have k, it's y equals 4x. Now we can substitute it in. Y equals 4 times 1 is 4. Y equals 10 times 4 is 40. Oh man. How do we go from the y back to the x though? What'd you do?
You have to times it by 4.
So 100 times 4? What? Divide it. So to go from x to y, we multiply. To go from y to x, we divide. 100 divided by 4 is 25. Y'all, this is direct variation. Was this hard? You guys made the equations. You found the constant. Could I graph this? Now, watch this. Here's my question for you. I'm going to erase this. This would be too big to graph, right? Nobody wants to graph 25, 100. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1 rose, $4. Could I do 2? Why not? Because I can. How much does 2 roses cost?
Oh, 8.
Oh, even though it's not in our table, we can find it out because it stays constant. Now, I want you to kind of pay attention. This is going to be later on. But we know that 0 roses cost $0. The constant is 4, which is up 1, 2, 3, 4 over 1. What's this? Up 1, 2, 3, 4 over 1 is 2, 8. Huh. That's going to be important. Y'all, I am so proud of you. I look, like, truly, look at me. Really, really proud of you. You guys got that. That's awesome. We're going to add a little bit on, and I know I was like, oh, you're making it confusing. Tomorrow's going to be a little bit more confusing, but if you can find the constant, you guys are going to do great. Questions? Okay, no homework tonight. Love y'all.